Hello. In this video, we present the synthesis of phenobarbital labeled with nitrogen-15 or with carbon-14, according to its retrosynthesis presented in a previous video. Phenobarbital labeled with nitrogen-15, starting from carbon dioxide and labeled molecular nitrogen, generates labeled urea when it reacts with substituted malonate produces the phenobarbital labeled with nitrogen-15, as we will see later. The production of urea labeled with nitrogen-15 uses an electrocatalyzed carbon-nitrogen coupling in an H-type electrochemical cell, using a hybrid support between p-perovskite, trioxide of bismuth and iron, and the N-perovskite, tetroxide of bismuth and vanadium. Under these conditions, the adsorption of carbon dioxide is favored on the nucleophilic part and the labeled molecular nitrogen on the electrophilic part. The reduction of carbon dioxide with water elimination generates adsorbed carbon monoxide on the support material. The carbon monoxide inserts between the two adsorbed nitrogens to generate the tricyclic intermediate. Another reduction in the nitrogen-nitrogen bond leads to labeled urea with nitrogen-15. Through two condensation reactions between labeled urea and the substituted malonate 4, whose synthesis was already presented in a previous video, labeled phenobarbital is produced with a yield of 24%. Labeled phenobarbital with carbon-14. Starting from labeled barium carbonate with cesium amide, labeled urea is obtained, which, when reacted with substituted malonyl dichloride. Through condensation reactions, labeled phenobarbital with carbon-14 is produced. The reaction between the labeled barium carbonate and cesium amide results in the urea labeled with carbon-14. The hydrolysis of malonic ester 4 produces substituted malonic acid 9, which, when refluxed with phosphorus pentachloride, yields malonyl dichloride 10. The condensation reactions between the labeled urea 8 and the acid dichloride 10 generate the labeled phenobarbital with carbon-14 with 48% yield. In summary, the raw materials and their structural contribution for both synthesis are shown here. Thank you for your attention.